Welcome to Operating Systems Unit 13. Today we're going to just talk some more about page replacement, global versus local, that's just a review, and frame allocation and the concept of thread. So what happens if there is no free frame? So we have to select a victim page that needs to be replaced. And there are different techniques that can be used to do that. The first technique is to use a local page replacement, which means that you have to select from your own pages, or a global page replacement, which means that you have to select from those pages that are on other processes. And another thing that you need to take into consideration when you're selecting a victim page is whether or not that page has been modified while it was in the frame, because if it's been modified, you're going to have overhead in having to write back the information. If it has not been modified, then it can just be replaced. So those are things that need to be taken into consideration when you are setting up your paging scheme with your operating system. So one thing that you can do is use two things is a frame allocation algorithm and a page replacement algorithm. So the first thing is a frame allocation algorithm. Now this has to do with determining how many frames you're going to give per process. And what that means is this would be for a local page replacement setup. So you're going to make some determination in your system, maybe based on the size of the process, the importance of the process, but you're going to make the process select, when it comes time to select a victim after you've filled all the frames of all the pages that have been allocated to that process, and when that process needs a new page, it's going to have to select a victim from its own frames. That would be using a frame allocation algorithm. And a page replacement algorithm also is going to be based on local page replacement. So in this video, we're going to talk about the frame allocation algorithm, and in the next video, we're going to talk about page replacement algorithms, and those page replacement algorithms will be based on local page replacement and on demand paging. So first, let's talk about the allocation of frames. Well, there's a situation that each process needs to have a minimum number of frames to do a particular task. So if you do not give enough frames per process, what can happen is that the process will continue to ask for frames, and you will continue be assigning frames to it, and then it's not getting any real work done. So it's very important to realize that. And then there's a maximum frames that are available in the system. So if you have these maximum number of frames available in the system, you have to disperse them in a way to the processes so that you are not exhausting the availability of all of the memory that's available to these processes. So there are two major schemes in order to allocate frames to processes. The first one is a fixed allocation, and the other is a priority allocation. And of course there are variations on these, but these are some examples and exercises. So the fixed allocation says that you're going to give an equal allocation for each process. So what that means is if you have, say, 100 frames available and 5 processes, you're going to give 20 frames to each process. And then if a process doesn't even need 20 frames, then you have extra frames that could be available globally in a pool for processes to use. Another way to allocate frames is to use proportional allocation, and that has to do with the size of the process. So this is an exercise right here to describe how that works. So SI stands for the size of a process. So S1 would be the size of process 1, S2 would be the size of process 2. Then capital S is going to be the sum of all of the size of the processes. M is going to be the total number of frames available, and then allocation, you're going to allocate per process based on a ratio of the size of the process with a ratio with the size of all the processes multiplied by the number of frames available. And so it's better to do it than to just talk about it. So let's say, for example, you have 64 frames available, and process 1, the size of process 1 is size 10, and process 2, the size of process 2 is size 127. So the total of the two processes is going to be size 137. So that would be capital S. So if you took the allocation for process 1, you would take the size, the ratio, the proportion of the size 1 and the over the size of all of those, and then we're only doing with 2 here, but this can apply to certainly more than 2 processes, and multiply it times the number of frames available, which is 64, would mean out of those 64 frames you would give 5 to P1 because it's much smaller, and you would give 59 to P2 because P2 is certainly much larger. So that's one way in which the frames can be allocated per process, and that would be a local frame allocation. And so when page replacements goes to happen, when the process would then choose from its own pages in which to replace. A priority allocation just uses a proportional allocation using priority as a basis. So this can happen because obviously, as we've learned, there are processes that have higher priorities than other processes. So you want to make sure that those higher priority processes are getting the frames that they need. Thrashing is a concept that happens in a system when the system starts to, when processes are not getting the minimum number of frames necessary to do the most basic tasks, so they're requesting more pages. And as they're requesting more pages, the system thinks that, oh, our system is not doing much work, so I'm going to introduce more tasks into the system, and therefore they're still not getting enough frames, and so the system basically ends up just swapping pages in and out and paging and paging and paging, and no real work is being done. And I've scanned in the pages from the book, and I suggest also very strongly that you read the few pages in the book on thrashing, because the textbook does explain that very well. And one way to deal with this situation is you take a working set window, and that means you just take a little set, and it has to be defined on how large this set should be, and you take this set and you figure out a locality. So say, for example, this string, this represents pages that have been referenced. So this process referenced page 2, then 6, then 1, then 5, then 7, then 7, then 7, then 5, then 1. So if you pick a delta, which says, okay, how many references were made, so this delta is a particular size, and then you say, okay, in that section, this working set, then the pages that were referenced here were pages 1, 2, 5, 6, and 7. And then the same working set model later on, the pages that were referenced here were page 3 and 4. So you can use this information in order to make some decisions about the number of frames that should be available for the process by seeing in these working set how many pages were actually being accessed by that process. So there are a lot of techniques that can be used to try to manage paging in a system. Page replacement we will talk about in the next video, but you can do page replacement globally or locally. How many frames get allocated per process, and then this concept of thrashing that can happen because the system is thinking that there's no work being done, but in truth there's no work being done because the processes are not getting the number of pages needed. So thank you very much, and you'll hear from me in Unit 13, Part 2.